Hi everyone, how's it going? My name is Daryl, welcome back to my channel. This project has been developed a few months ago, which is to use gesture to take selfie with the use of Python. And I finally have some time to record it and go through the details with you. So I hope this is useful to you. The first thing that we are going to cover is setting up with the MediaPipe, which is the core framework. And then with the use of MediaPipe, we are going to detect our hand pose and make inference by applying the hand landmark model. Finally, on top of that, we will set up some logic to detect our gesture, and with the correct gesture, it will trigger the selfie. For this project, we are using a webcam, and of course, you can connect this with your mobile phone or any handheld device for further development. Ready to go? Let's get started. Before we dive into the agenda items today, let me give you a brief overview of MediaPipe. MediaPipe is an open source framework developed by Google for building multiple models cross-platform applied machine learning pipelines. So it is performance optimized with end-to-end on-device inference. Here are a number of solutions that is offered by the MediaPipe that includes the face detections, face mesh, iris detections, hands detections, pose detections, segmentations, object detections, box trackings, and so and so. What we're going to do is that we're going to dive into the hands detections. So these are the solutions offered its MediaPipe, and this is the ability to detect the hands, and then based on these hands detections or the palms detections, it will then use a hands landmark model to detect the 21 coordinations within your hands. So let's move on to the first agenda item. First thing first, we will bring in two libraries. One is the MediaPipe and the other is the OpenCV. MediaPipe is here to help us to detect the hand pose, and once we have these detections, we would like to use the OpenCV to show us the results. So if you do not have the MediaPipe or OpenCV under your platform, so please feel free to use the pip install methods to install the MediaPipe and OpenCV. Once we have these two libraries, we can import them into our platform. The next thing that we want to do is to detect the hand pose with the hand landmark models. The hand landmark models involves two steps. The first one is the palm detections model. It helps us to handle some challenge. Say, for example, the varieties of the hand size, it depends on your hand's locations inside in the webcam. Say, for example, if I put my hand in front of the camera, closest to the camera, my hand is larger. If I put it a bit far away, and of course the hand size is a little bit smaller, relatively. So it has to deal with this variety of hand size. At the same time, it also needs to deal with the issues of lack of specific features. It's because if, say for example, if we are working with the face detections, we will have our eyes, our mouth regions, and our nose, our hair. That kind of features will help us to detect the face much more easier. On the other hand, if we want to detect our hands because its lack of these specific feature, it would be rather difficult for it to do it accurately. So to solve these problems, media pipelines have three different strategies. First of all, it trains a palm detector instead of a hand detector directly. So in that case, it will use a palm detector to estimate the bounding box of the widget regions, like the palms, like the feet, something like that. And then once it has the palm detections, it will perform a encoders and decoders feature extractions, which is used to extract the features from a bigger scenes. So even you have a smaller objects, so even you have a smaller size of your hands with the cameras. So in that, and finally, it will help to minimize the focal loss during the trainings to support a large amount of angles resulting from the high scale variance. So it doesn't matter your hands inside where in the picture or inside the frame. With the above technique, it solves the problems and it improves the accuracy. Once we have the palm detections over the whole image, a subsequent hand landmark models will be performed. It performs a precise key points location localize of 21 points 3D coordinates inside these detected hands regions with the use of regressions. So this is like a direct coordinate predictions. And here are the landmark models, are the results of the landmark models. For further reference, please feel free to go to this link and it will provide you more information. All right, now it's time to play around with the model. Let me switch to another camera to better illustrate the result. First thing first, we would like to bring in the hands module from these MP-Doc solutions. Because as just like what I mentioned before, there are a number of solutions that is provided by these MediaPipe framework. And for this one, we would like to bring in the hands models, and then we will assign it as the MP hands. Once we have this MP hands module, we would like to use the hands objects methods. So we will assign it as hands. Now let me show you what we have here. And just like what I mentioned, the first assignment is a module. We would like to bring in the module, the hands module from these MP-Doc solutions and assign it as the MP hands. And once we have these MP hands, we would like to assign it as a hands object. So once we have these objects, we would like to assign it as hands. So these are the two things that we would like to assign with the use of MediaPipe framework. Once we have this framework, we can output the result. And just like what I mentioned, I would like to use the webcam here with the OpenCV, with the use of OpenCV framework. Let me also bring it back with these two assignment into this cell. These codes are normal settings to capture the screen from the webcam. So there's no detections at all at this point. Say, let me go through the codes one by one. Here, we would like to use the video capture methods to capture the screen, capture the frame from the webcam, and then assign it as the cap. And while true, it means that we're going to continue to read from this video capture. So for this one, we are going to, for these cap objects, we are going to use dot read methods to read each of the frame. And it will show me two things. The first parameter, the first results that is going to show me is whether or not we can capture anything from this webcam. And if not success, it will just break this while loop and end this capture. And on the other hand, it will show me the image. If it is successfully captured at capturing anything, it will show me this image result, and this image is for each frame. So what I can do is to use the cv2.imshow to show the image, And if there are any, if I would like to quit this loop, I just press the Q buttons to break this loop. And finally, once we have these everything's captured, have everything set up, we would like to release the capture and destroy it in the windows at the end. So now let me show you what is happening here. All right, here we go. You can see at this point there's no detection at all. So let me press the Q to end this video capture. Excellent. Now we have this basic setup. What we want to do next is to convert the image from BGL, which is applied by the OpenCV, to RGB, which is used by the MediaPipe. We need to convert it from BGL to RGB. And once we have this RGB image, we will then use it to make the detections with the use hands landmarks models. So I just copy everything from previous cell. What I want to do is to convert the image from RGB, that is from BGL, sorry, that is the BGL, and then to RGB, So we are going to use OpenCV to one of the methods, that is to convert the color. And then for the first argument is the image that we just captured, but that is the BGL format. So we would like to convert it to RGB. And then we will assign it as the image RGB. And once we have this RGB image, we can then make detections with the dot process methods, and all the results will be stored in this result here. Now, if I run this cell, let me put my hands up first, and then let me quit. And let me show you what's inside these results. First, let's take a look on the class that we have from these results. So this is a class that is the class is a MediaPipe solutions based on these solutions outputs. That is the output class from these MediaPipe. And then let me print out the hands landmark, and based on these output results. And if I want to have the hands landmark, and I will use these multi-hand landmarks under these result outputs. So here we go. You can see this will give you the 21 coordinates, 21 points with their corresponding coordinates under these hands landmark results. So if I want to retrieve the result, I need to use these results dot multi-hands landmark. And in this example, I just showed you the coordinates of one hand, because I just put one hand in front of the cameras. So the hand landmark models allow us to detect multiple hands. So what if I have multiple hands? What happens? So if I use this picture and make a detections. Now let me show you the result. So for this times, I will use a for loop that is for hands landmark inside these result dot multi hands landmark, and that is how we achieve the result previously. And for this times, we use a for loop because we have two hands. I just use this to separate the two hands just to better illustrate. Now you can see this is for the first hand that we have, and then this is the second hand that we have. So we have two hands. As a result, for each of the hands, we have the 21 coordinates. So to better retrieve the result, we can actually create another for loop inside this for loop. So for the first for loop, it's used to retrieve each of the hand. And once we have each of the hand, we would like to print out each of the landmark in each of the hands, and then separate them by their corresponding locations and their landmark. So let me print you out the result. That is to print the ID and print the landmark. The ID means the landmark, and the landmark is the landmark's coordinate. So now you can see this is for the first hand from 0 to 21. That is the 20. That is for the first 21 coordinates, and then another hand that is from 0 to 20. That is for the second hand. So the next things that we want to do is to capture the landmarks and their associated coordinate, and then draw the landmark. Let me copy back the previous models that we have. So for this one, these models, we do not have any, we only have detect the result. We still haven't showed the results yet. Now, because the coordinate here is relative, so we need to provide the shape of this image in order for it to provide the absolute coordinate rather than these relative coordinates. So what I want to do is first is to capture the size of this image, and then once we have this size of the image, we would like to check whether or not there is any result, there's any detections of the hands. So if there's no detections, so just skip it. But if there's if there's any detections, and then it will just go through the two loop that I just mentioned previously to retrieve the landmark and also their corresponding coordinate. Once we have these landmark, we would like to, this is the landmark, I would like to retrieve the x coordinate and also the y coordinate, and then times the width and also times the height, and it will return you cx cy and in the absolute coordinate. And once we have these cx cy coordinate for each of the landmark, we would like to draw for example, draw a circle in this cx cy. And so here you can see this is the image that we have. We are going to put a circle in with their corresponding locations, and then this is the way how we draw the draw the circle for each of the landmark. So this is we are going to fill this circle, and then this is the right color, and this is the size of the circle. And so these just a very quick recap. These first two steps is to convert the image from BGR to RGB, and this RGB image will be used to detect the hands, and then the results will be stored in this results variable. Once we have this results variable, we will then capture the landmark and their associated coordinate. These are the field lines that we have. That is to capture the landmark and their associated coordinates, and then draw the landmark. Because right now we just convert the relative coordinates to an absolute coordinate of the respective image, and then we will fill in a circle for each of the coordinates. So let me show you the results. And for this one, I forget to close brackets, and let me show you the result. Here we go, and you can see my hand. There's some tiny little dot over here, and let me resize it a little bit so that you can see it clearly. Again, now you can see two hands, so all the coordinates are here with the use of the medium pipes to detect my hands, and then with the use of the series to draw out the coordinates. Now let me change it back to 1. For the next step is that we would like to create a coordinate functions, because I'm not going to retrieve all the landmarks for triggering this selfie. Instead, I would like to retrieve some important landmarks to do that. So what I would like to do is to create a coordinate functions to do that. So these are the things that I would like to put inside a function. And say these are the things inside this coordinate function. We will take the ID, height, and width, and then calculate the absolute coordinate for each of the landmark, and then draw the circle for each of the landmark with their respective coordinates, and return the absolute coordinate for the useful landmark. So say if I think the ID is equals to 0 is useful, and ID is equals to 10 is useful, I will just pass it on to this coordinate function. Yep. So it will return you the CX, CY. So let's say for the ID, if that is equals to 0, I will pass 0 ID to these coordinate functions, and it will only retrieve the landmark with the 0 ID, and then retrieve that back to the absolute coordinate for me, and I will just rename it to CX0 and CY0. And similarly, for this one, say if I would like to retrieve the coordinate of the landmark point, and I can do the same thing. Pass it on to the coordinate functions and then return me the CX60, CY0 for the coordinate 0 and for the ID 0, and then for 610 CY10 for the coordinate 10. So we just create this coordinate function. Now let's take a look on that. Okay, maybe I just again let me change it to larger size of the circle, and you can see this is the ID 0 and this is the ID 10. Now we have these coordinate functions. We can set up some logics to trigger the selfie. The gesture to trigger the selfie is like this. So let me show you. Is that we hold up our palms and then we close it, and then it will trigger the selfie. So in that case, we would like to our hands face to the cameras and hands up. So the first logic that we would like to have is hands up. So let's set up these logic. So let me copy everything from this cell and then put it over here. The first logics that we would like to have is to detect whether or not our hands is facing up, hands up. For this one, I do not want to confuse you, so I just remove these CX coordinate. We do not need that, so we just need the CY coordinate. And I also set the hands up equals to 0. And if I set it as a 0, it means that the hands is not facing up. So only if it's facing down, it will turn it to 1. So by default is equals to 0. Before we set up the logic, one thing that I would like to show you is the coordinate systems on OpenCV. On the top left corner, that is the 0, 0, that is the origins. And then if we go further downward, and then the value of y coordinates is getting higher. So that is the coordinate system on OpenCV. So to check whether or not our hands is up, we check the ID 0, that is our whisk, and the positions of our whisk, and also the positions of our middle fingers, that is ID 10. And in that case, we check these, we check against the coordinates y against these 0 and 10. So what I would like to do is to check whether is to compare the coordinates of the whisk and also middle fingers. If our hands is up, and then we will just set the value equals to 1, and if our hands is down, and we will set the value equals to 0. So let's run this cell, and then let me show you. This is the hands up, and let me print out the result for you. So this is the hands up, and you can see that the coordinate of our middle finger is less than the coordinate of our whisk. In that case, my hands is up. The next things that I would like to check is my thumbs. 2 points that I would like to retrieve, that is the landmark 2 and landmark 3. And let me show you why I would like to check these two landmarks later on. But here I would like to retrieve the landmark 2 and landmark 3 and check whether or not our thumbs is correctly positioned. And then I will set up the logic. And the logic is that I want to make sure these coordinates CY2, CY2, and CY3, CY3 are within these CY10 and CY0. What it means is that I would like to make sure 2, 3 is in between 10 and 0. So why I would like to do that? Let me run this cell. It's because sometimes I can turn around my hand. And in that case, you can see that the 2 and 3 here is not within these 0 and 10. So I need to make sure that is face up and also not turn into any other positions. I do not want to have a turn on my hand. I want it strictly facing up. That is the whole point. So now if I check the logic, you can see that both of the coordinates of 2 and 3 are within 0 and 10. So the thumbs is correctly inside these in between 0 and 10, and it means that our hands does not turn around. It's strictly facing up. So let me show you what happens if I turn it a little bit over here. Say we go say here, and you can check back the logic, and here you can see that they are outside the 10 and 0, outside 10 and 0, and in that case our hand is not strictly facing up. Finally, I would like to check the logic against my fingers, and in that case I would like to retrieve the ID 5, 9, 13, 17 of the bottom of each of the fingers, and also retrieve the 8, 12, 16, and 20. That is the tips of each of the fingers. I would like to retrieve these 8 coordinates. So what I want to do is to retrieve these 8 coordinates and set up the fingers correct logics, and then I need to check against the logic of the fingers. And now let me paste these logics first, and let me show you the result. Okay, here we go. So this is the 5, 9, 13, and 17, the coordinate, the bottom of my fingers. And then you can also see at the tips of each of my fingers, I also retrieve their coordinates. And then for these logics over here, is that if I close my palm, close all the fingers over here, you can see that the fingers, you can see that the coordinates now is of my tips of my fingers is bigger than the bottoms of my fingers. So in that case, is closing palm. And now let me show you the result. You can see all the fingers are correct, and the fingers logics is correct as well. But what if I have two finger does not close? What happens? So you can see two of them are not correct and two of them are closed. Now we are ready to create the selfie. Let me put everything over here. And then outside these while loops, I would like to make an initial conditions for whether or not we should take a photo at this point. So originally we set it as 0. It means that we are not going to take any selfie at this point unless all the logics are correct, all equals to 1, until all the logics are equals to 1, and then we will take a photo. In that case, I want to create a simple countdown function. So I just set the take photos equals to 120. But just in case, if you do not want to have that countdown, you can just simply create the selfie over here, or simply write the image over here. So in that case, it will just help you to take the photos right away. But let me show you how to create that countdown. Again, the logic is not too difficult. So if take photo is larger than 1, because this is 120 is larger than 1, it will just come over here. Because this is 120 that is larger than 19, in that case, I will continue to show the value 3 in the middle of the image. Okay, so I will use this cv2.putTest over the image with a number 3 in the middle of the image, and then it will continue to -1, and that means it will continue to reduce these value 120 for each frame. It will reduce 1. And then what if that is no longer larger than 19, but if it's larger than 60, in that case I will show you a 2. And then finally, once it continues to reduce for each of the frame, and then if that is larger than 30, that it will show you the 1. And finally, if the take photos equals to 1, I will take that selfie. And finally, it will return a take photos equals to 0 and allow you to take another selfie after that. And the image will be saved in the current path and with the name photo.jpg. And of course, you can just change whatever name that you want. I found that there's a typo over the fingers in this cell, so let's change it, remove the typo, and then because I typed it wrong in the previous cell. Okay, so now let's take a look on this selfie program. So here we go, and this is my hands, and if I close it, it will just take the countdown, and then it will just take a selfie. Here we go. And once it take a selfie, let me show you the result. And it will be inside the folder. And here we go. You can see that in the current path, and the photo is just taken. So the full code, I will provide it right here, and you can change it back to the webcam, and you can download it from my GitHub and use it right away. And I can also show you the selfie, and by using this Series 2 I'm with the photo. And here we go. This is the selfie. Of course, this is one of the ways to set up the logics of your gesture. You can feel free to change the logics and play around with it. I hope you enjoyed it. Please subscribe, like, and share. And if you have any questions or suggestions, or even any projects that you would like to share, please feel free to let me know in the comment sections. See you in the next video. Bye bye.